Hi everyone, welcome back. In this video we're gonna look at special relations which we call functions, and I imagine you've already heard of this word a lot of times, and for good reason, because the concept of a function is used so much in mathematics. It has so much applications. For example, the AI which we are building towards. So what do we actually mean by a function? Well, a function f, the f for function, of course, between two sets x and y. Well, this is a relation, some special relation, so we're going to add in a condition such that for every element in x, there exists exactly one. There exists a unique or exactly one element y, so that it holds that the tuple xy is actually in this relation. Remember, a function is a relation. A relation is a subset of the product x times y, so the elements are indeed tuples. Take a moment to think about what this definition actually means. Well, let me give you an example and a non-example of functions. So sets x and y here. Let's say we have three elements. I'm not going to name them here, and I have two elements. I'm going to draw this again, x and y here. Oh, x and y, three elements and two elements. Okay, so what I could do, I want to make a relation. I'm going to make this guy go there, and this guy go there. Well, this is not a function because this element here doesn't go anywhere. So this is not the first element of the tuple of the function. So this is not one. I could try and make it into a function. This is a function, but if I then send this guy also to this one, then again, this is again no function, because this element now will appear twice as the first element of the tuple. This one. Well, what I can make is, of course, I can just easily send everything to one thing, and this is, of course, just an example of a function. Yes, indeed, because what does it say? That every element of x is mapped to one element of y. And I use the word mapped here because I actually use these arrow notation. This you can really read as this element is sent or mapped to this element is also sent to this element is also sent to that element. And of course, we want to be able to use some notation to write this very concisely. We can look at the function f. This is the name of our function. And then a colon. We indicate that we start in the set x and we go to the set y. And then we say that every x here is actually mapped to a certain element which we call f of x, and this is often y. And now we can understand, for example, this plus function. We start in all the tuples of rational numbers. We end up in the rational numbers, and a tuple here, a times b, ab is mapped to the sum of a plus b. So now we understand everything to read this function. What does it actually do? And then think about it. If x and y are actually the real numbers, how you would actually represent this diagram here, because now we have an infinite number of elements. Well, we can draw actually here my x-axis and my y-axis. And then, for example, if you look at the function that goes from r to r, which maps x to, let's say, x squared, so this is my f of x, then I can draw all those points x squared that lie in the plane, and then you can actually, what you're actually drawing then is the graph of the function. And this is indeed a function because every element in the set where you start from, which lies here on my x-axis, is mapped exactly to one element of y. And try to come up with a few other examples yourself. Ciao.